Hi guys, please like, share and subscribe. And if you want full course for any actuarial subject, visit theactuarialguy.com or WhatsApp on this number. Thank you.
Okay, so now I want to get into one important question, that how does a country or an economy decide its production mix? What does production mix mean? That how does it allocate various goods to decide that I will produce so many units of good X and so many units of good Y, right? So for example, let's take example of an economy where there are only two goods, right? Either you can produce food or you can produce clothing, right? Let's say there are no other options, and the reason I'm assuming this is to simplify our analysis, right? So now there is only food and clothing. So how much of food to produce and how much of clothing to produce? How does a country decide that? So for that analysis, we'll get into the idea of production possibility curve, or it is also referred to as production possibility frontier, right? So what does a production possibility curve or frontier represent? It represents all possible combinations of two goods that a country can produce within a specified period of time with all its resources fully and efficiently employed, right? So we assume that all resources of the country are 100% employed, they're fully employed, and then we try to analyze which one are they going to produce in one quantity, and how will that impact the production of the other, because resources are limited, right? That is a fundamental problem here, that you have your resources which are limited and you are efficiently or fully employing them, efficiently and fully employing them, right? Then how much do you produce of each of the good, right? So that is the analysis that we are now going to get into. So now let's say the two goods that we are producing are food and clothing, as I discussed. And these are various combinations of the two that you can produce employing all of your resources. Now, let's consider the extreme cases first. Let's say you decide to produce only food and no clothing. Obviously, that would cause a lot of political distress in the economy. People will be like, there's no clothes to wear. But let's just hypothetically assume there are no consumption constraints, there is no political pressure, you're only looking at what is possible from a production point of view. That's why it's called the production possibility frontier. We are looking at production in isolation. So if all of the units of labor, capital and natural resources are employed only to produce food, then you can produce 8 million units of food. Similarly, if all units of labor, natural resources and capital are employed to produce clothing, you can produce 7 million units of clothing, right? These are the extreme outliers. In this respective case, the production of the other commodity is zero, right? So that is the idea that we are discussing here. Now, how does this scenario change if I try to increase the amount of let's say food slowly? Okay, so we will go from the bottom upward, right? So let's say if I want to produce 1 unit of food, at least 1 unit of food is what I need. How many units of the clothing will I have to let go? That is the question, right? So the answer for that is 0.3 units of clothing, right? You will have to let go some amount of clothing. It's not like you can still keep on producing 7 million units of clothing. You will have to reduce your clothing production. Okay. Now let's say I want to produce one more unit of food. Let's say I want to go from 1 unit to 2 units of food. How many units of clothing will I have to let go of? This time again, I will have to let go of 0.3 million units of clothing, right? So what seems to be the case is that every unit of food, when I increase its production and when I divert my resources from clothing to food, when I divert my natural resources, labor and capital into production of food, the opportunity cost of producing one unit of food is 0.3 million units of clothing. That seems to be the case so far. But as you go upward, you will see something changing. When I want to produce another unit of food, then this time I will have to reduce my production of clothing by 0.4 million units, not 0.3 million, right? So the opportunity cost of producing one additional unit of food this time is 0.4 million units of clothing, right? And finally, if you go all the way up and you're moving from 7 to 8 million units of food, you will have to let go 2.2 million units of clothing. So what is happening is that your opportunity cost is increasing through this production process. As you substitute more and more clothing with food, you have to let go of more and more clothing for every additional unit of food, right? And this is because when you're firstly reducing your clothing and you're sending some of your resources, you're diverting some of your resources towards food, you will divert your resources who are the best at production of food, right? Let's say you have some laborers in your economy or some farmers in your economy who are exceptional at production of food, right? So these few guys, they were anyway not good at production of clothing, they were exceptional at production of food, and they would be the guys who would volunteer first to move to the production of food because they know they can do the job the best, right? So when these resources move from clothing to food, only a very few people will be able to produce the first 1 million units of food. Then when you keep on increasing your production of food and you keep on reducing your production of clothing, people who will not be as good farmers as the first batch which went into food will keep on moving, right? So every time they will be less productive in the production of food, and you will have to send more and more people out of your clothing industry into the food industry to produce the additional million units of food. And finally we come to this point where, at the last point, where only a very few people are anyway remaining in clothing and almost everyone is in food, and when I still push this last batch of people into food, these will be people who will be exceptional at producing clothes, right? So I would lose a lot of clothing production if I send them into food, because they are anyway very efficient at production of clothing and not as efficient at production of clothes, because they are the ones who have remained the last, right? They are the ones who is the last to move. So the assumption is that they'll be the worst at production of food and best at production of clothing. That's why they have not moved so far despite so many opportunities to move into food, and thus this will cost you hugely, right? So that is why you see that you have a sort of increasing opportunity cost as you increase the production of one commodity at the expense of the other commodity, right? And this is called as, one name for it is increasing opportunity cost in production. The other name is for it is marginal rate of transformation. When you're transforming your economy from one good to another, right, you have an increasing marginal rate of transformation. This name is not given in the Sloman book, it's not given in the CB2 material. They just refer to it as increasing opportunity cost, but it is also called as marginal rate of transformation, right? So this is something you should know. Now let's try to represent this graphically, right? So this is what this data, if I plot it, this is what it would look like, and this is called as your production possibility curve, right? Let me just show you what I'm talking about. So let's say you were at, let's start top down this time. So let's say you were at 8 million units of food and 0 units of clothing. So you are at this point, right, which is 0,8, right? Now if you increase your production, if you decrease your production of food by 1 million units, right? So you want to get at 7, right? Where will you get in terms of your production of clothing? You will get to 2.2 units, right? So it'll be somewhere here, right? So it is this point, right, which is 2.2 comma 7, right? Then if you want to let go one more unit of food, you will get to 6 units, right? You will get to 6 units, and this time you will have 4 units of clothing, right? So this is 4 comma 6, right? So on and so forth. So this is what your curve will look like, right? You will see that two properties are there for this one, it slopes downward. Okay, there are two properties that I want you to note. That first one is slope downward, right? What is the reason for that? The reason for that is, at this curve all of your resources are employed already. So in order to produce additional units of clothing, there is no option but to reduce the units of food produced, because you will have to divert resources. All your resources are employed at this curve, right? So in order to increase one production, you will have to reduce the other production, right? So the reason for that is, at the curve all resources are fully and efficiently employed. To increase the production of clothing, production of food needs to be reduced, right? That is the idea, and that is why this curve is downward slope, right? Let's talk about the other property, which is that this is sort of bulged out, right? Or let me use the word that the uh, book uses, it's bowed outward, right? It is concave in its shape, right? That is what such curves are called, concave, but the book calls it bowed outwards. You can see this bow kind of a structure which is going outward, right? So that is the idea. It's bowed outward. And what is the reason for that? The reason for that is to get one additional unit of clothing, you have to let go of more and more units of food, right? To get one additional unit of clothing, you will have to let go of more and more units of food, because the best people move the first, and the people who are the worst at producing clothing would move the last, right? So that is because of increasing opportunity cost, right? So the curve is bowed outward, and that is because of increasing opportunity cost in production, or you can also call it as increasing marginal rate of transformation, right? So these are some of the things that you need to know about this curve, right? That it's one, downward sloping, because resources are fully employed, and to increase the production of one good, you will have to reduce the production of the other good, and it's bowed outward. So uh, there is an increasing opportunity cost of production, right? So these are the two things that you must know. Now uh, let's answer a couple of questions about this production possibility curve. The first one is, what is the opportunity cost of the 7th million units of clothing? So what is the opportunity cost of the 7th million, right? So when you move from 6 to 7, right, how much are you letting go in terms of food, right? That is what they're asking. So when you go from 6 to 7 in terms of clothing, you are letting go 3 million units of food, right? That is your answer for this. So the answer for this is 3 million units of food, right? 3 million units of food. Reason is that when you go from 6 to 7, you can see in this table, right? When you're going from, let me erase everything else and show it to you, right? When you're going from 6 to 7 in terms of clothing, in terms of food, you go from 3 to 0, right? So 3 million units of food is the opportunity cost of the 7th million units of clothing, right? The last one, right? Now if the country moves upward along the curve and produces more food, does this also involve increasing opportunity cost? Yes, this is something that I started with, right? So if you move upward, that is what I gave you the example of, right? The book would typically have given you the example of moving downward, which is what we talked about when we were talking about it from the point of view of uh, the curve, right? But when I discussed the table, I moved upward, right? And that is there as well. You were seeing that to produce one additional unit of food, you were having to let go of more and more clothing as we progressed ahead, as we substituted clothing with food, right? And now, under what circumstances would the production possibility curve A be straight line, bowed towards the origin? Are these circumstances ever likely? Okay, so now they're asking, is it possible that one, your production possibility curve is a straight line, and the other possibility they're asking for is that it looks somewhat like this, right? Or let me even connect it with the, yeah, somewhat like this, right? So are these two situations possible? That is what they're asking. Okay, let me tell you the answer. See, uh so both of these situations are possible. This is if you don't have, if you have a constant opportunity cost
in production, right? If you had increasing, you had that curve which was bowed out. If you have a constant opportunity cost in production, so for every unit of X that you will produce more, you will exactly let go of equal unit of Y, right? This slope is constant, the slope is not changing, right? This part is equal to this part, right? This is if you have a constant opportunity cost in production. When does that happen? That happens if your population is equally good at producing both food and clothing, right? The population is in reality it's unlikely because people are good at different things, different people are good at different things. But if theoretically your population is equally good or your resources are equally efficient, if I say population it would just limit to labor, but I'm talking about all three: natural resources, uh, labor, and uh, capital, right? So resources are equally good at producing both goods, right? That is when you would have a straight line production possibility curve, right? So that is the answer for this one. Why is this unlikely? Because see, this would mean that in your country you have equal amount of uh, you know thread which is required to produce uh, the clothing versus equal amount of grains which are required to produce clothes, right? So and they can be grown equally easily in your country, right? But climates across the globe are different. Some climates are more conducive to growing grains versus some are more conducive to growing textile crops, right? Similarly, different people have different skills, right? So your population cannot be equally good at producing both clothing and food, right? And similarly, your capital, the kind of equipment you have, it can either be suited to producing food or clothing. It's not interchangeable. You can't directly move all of the equipment from food to clothing, right? So it's a very theoretical scenario, right? um, let's talk about the other scenario that they're asking. Can your production possibility curve be bowed towards the origin, bowed inwards towards the origin? Well, that represents a scenario where uh, what is happening here, if you see, for every additional unit of um, let's say this is food and let's say this is clothing. So every additional unit of food, for every additional unit of food, initially the amount of clothing you have to let go is very high, but eventually the amount of clothing you have to let go is very low, right? Now this is an even more unlikely scenario, that initially you're letting go of too much clothing but eventually you're letting go of very less clothing, right? What is the reason for that? The reason for that can be, or the theoretical scenario, again very unlikely, extremely unlikely, that can have this, if there is some complementarity in the production. So production of more of one commodity makes it easier to produce the other commodity. Okay, there is a complementarity in production. So when will this happen? When will production of one commodity make it easier for the other one to be produced? This is if one good is the input to the other good. Okay. So for example, one good is let's say yarn and the other one is t-shirts. Okay. So you need yarn to make t-shirts. So once you have enough yarn, it would become easier to produce t-shirts. right? When one good is in itself a capital good, and that is what the definition of capital goods was, right? That it's an input to the other production process of another good, right? So let's say one good is yarn and the other one is t-shirts. So if you have high enough production of yarn, it would become easier to produce t-shirts, and that is where you would see a graph which would be somewhat like this, right? uh, and then it has to be uh, concave on sorry, convex on both the goods. So for that, t-shirt will also have to be an input for yarn, right? uh, yeah, that is not true, right? So it's, you cannot have both goods being input to each other. That is a very unlikely scenario. I honestly can't think of it, right? So yeah, that is not a very realistic scenario, but I've given you something which is very close to it, right? Now let's consider a few more things related to production possibility curves, right? Now, as I told you, uh, at the production possibility curve, the economy is operating at full output level, right? That means that all resources are fully employed. There is full employment in the economy, right? Now, inside the production possibility curve, right, if let's say at this point V, this is where the economy is operating, it is underutilizing its resources. So it can produce more of one good without reducing the production of the other, right? So let's say from point V, I just want to increase the production of food without reducing the production of clothing. So what I would do is I would move to uh, X, or somewhere here is where I'll move, right? I would move here, which would mean my food production has increased, but the clothing production is practically the same as V, right? Or I can increase the production of clothing, right, without reducing the production of food, which is where I'll go in a straight line and I will go to this point, right? Or I can increase the production of both of them and then I can go to point Y, right? Because inside the production possibility curve, uh, the economy is not at full utilization of resources. Also, how is now growth represented in terms of a production possibility curve? Well, in order to represent growth, there's a shift in production possibility curve. So your production possibility curve shifts outward when there is economic growth. This happens over some period of time, obviously, right? So this is the representation of that. That when your resource pool itself increases, or the efficiency of your resources increases. So this is one thing I did not mention in the last lecture. So your capital, the efficiency of your capital can be improved with technological advancements, right? How to improve capital, okay? So capital can be improved with technological advances. If there are more advanced technologies for production, so you can produce more with less money, less capital, right? Less amount of that input which is going in, right? So technological advancements improve your efficiency of capital. Training improves knowledge and training. Education, basically, you can say. Education improves Education and training improves the efficiency of labor. And the way to improve natural resources is to find new natural resources. So a lot of times countries are able to discover new, uh, you know, uh, stacks of natural resources, right? I can put discovery of new natural resources, right? Right. So this is how uh, these pools can be improved over time, uh, and if any of these happen, your production possibility curve would shift outward. If economic growth happens, if your pool of natural resources increases, people save more. If people save more in an economy, and we'll discuss this eventually, their capital would increase, and growth would occur. And if growth occurs over time, your production possibility curve would shift outward, right? So these were some ideas that I wanted to discuss in regard to the production possibility curve. Again, it's a very straightforward, very simple topic, right? uh, I'll do some questions related to it soon, but yeah, thank you.